Nishant Malhotra, the sole founder, CEO of Middle Road OPC Private Limited, a for-profit social startup enabling social change and impact within the social impact system. Now, just a very brief about what my startup is about. My startup, it's a thought leader platform, the Middle Road, and it relies a lot on online learning, a lot of educational videos in finance and economics. There's something very specific in sustainable finance, e-publications. We have podcasts. So for podcasts, I call up leading experts and thought leaders from around the world, respective fields, who talk about their not only work experience, they talk about policies, they talk about what could be better within the global ecosystem. Dr. Chandrakant Lahariya is one of the foremost healthcare experts and thought leaders in Asia. Now, our conversation today is going to be dwelling into various aspects of the pandemic. Now, pandemic has been a huge disruptor. If you're trying to understand, in depth, there'll be a lot of global questions. There'll be a lot of also questions on particular specific topics. To understand more about pandemic, to understand more about viruses. So this is a very educational, I will say this is a educationally focused view which you could refer to. Dr. Chandrakant is a leading epidemiologist, policy and health systems expert based in India. He's also author of one of the fabulous book. I think if you want to read, I would highly recommend that you read Till We Win. It's an extremely insightful, informative and fluid book on COVID-19 and India's fight against the COVID-19 pandemic. But what's exceptional about this book, that's very global. It opens in a very fluid manner. You have a lot of instances to learn about, the backdrop of how landscape has changed in healthcare, global healthcare system, I would say in the last century or so. Chandrakant Lahariya is also the youngest fellow to be elected to the Indian Public Heath Association that works with leading healthcare experts to design healthcare policies and programs at state and national level. Now, he's very, very interested and passionate about universal and primary healthcare in India. And just to add one last bit, Dr. Gagandeep Kang and Dr. Randeep Guleria, they are the other co-authors of the book Till We Win. Okay, Chandrakant, delighted to have you here for a thought-provoking conversation.
Hi, it's my pleasure to be here.
What I want to share one very good aspect. In your book, you come to know about so many things. For example, Edward Jenner developed the first vaccine using cowpox virus against smallpox. So, small things which you come to know, who invented hand washing, and how much it enabled enslaving the lives of people. These are some of the things which I really loved about the book. And I want to congratulate you for being a co-author for such a fantastic book. Let's begin. You shared a very important in this book, this stunning reality, comparison, which I just wanted to share with my audience out here. Now, when we talk about viruses, if you take the number taking on our planet, it's about 10 to the power 31. Now you compare it with the humans, which is about 8 billion, at best is 18 to 10 to the power 9. So you could see the difference between the two. When we talk about bacteria and fungi, now virus, of course, is a much smaller in size than bacteria and fungi. But could you elaborate more about what could be the differentiating factors between viruses and when you're talking about bacteria and fungi?
So this is really fascinating that viruses are far too many than human beings, and viruses are actually far higher in the number on this planet than bacteria also. So the 10 to the power 31 essentially means for every single human being, there are 10 to the power 21 or 22 viruses. So that's a number which we know. But what we also need to remember that though we know that viruses do not leave fossils because they are not designed that way, but there are studies and there are experts who have looked at it, and they said that viruses have been on this planet for around 3 billion years ago. And when we again compare with human beings who came around 3,000 years ago, so 1 billion years ago and 300,000 years ago is when viruses have been here. They have witnessed, as they say, all the springs and all the seasons, and in the process, they have learned how to survive in difficult and challenging environment. We know that other species have extinct, but viruses have improved and they are here. One of the key things we need to remember is that over the period of evolution, viruses have learned how to shed the genes, which essentially means they were more complex earlier, and now they are a little less complex. And that makes them survival in the setting really effective and better. Now, one of the things which we need to remember that we keep hearing viruses, bacteria, and fungi. One of the key difference between viruses and bacteria and fungi that while bacteria are independent cell, or even fungi are independent cells in the sense that they can multiply their own, they have their own life. But viruses do not have that kind of mechanism. Viruses are made of genetic material covered in a protein. So if they are lying on the surface, they are able to multiply, replicate. So viruses need a cell. That cell could be a plant cell, human cells, or even bacteria anywhere. So viruses, that's a key difference. And that makes them that they can be on the surface, they can last for longer, and then for millions of years or even hundreds of thousands of years later, if the same protein and nucleic acid is found a cell, they will start multiplying. So that's the key difference, and that makes them survivable. But also we need to remember that they play, viruses, bacteria, fungi, all the microbes play a very important role in this evolution of human civilization or evolution of the planet, because they play a role in decaying of the dead things. They help in different processes, but unfortunately sometimes they can cause the kind of disease which we are facing now. But they have been part of the ecosystem which we are living in, and as humans we need to learn to live in the real harmony with the environment, and that's what would make this place better.
Look at most of the viruses are not harmful to the human species. Would I be correct?
Well, we can say that viruses do not play that much of important role, while bacteria and fungi are actually, some of them are very useful. For example, some of the bacteria produce vitamin B12, which cannot be produced by the human beings. And so it's really essential for survival. We know there are good bacteria which are on our skin surface. Our skin has many more bacteria, the other aspects, and they are not always harmful. As far as viruses are concerned, they do not have a very important role in human. But one of the fortunate part is that most of the viruses are hidden far away from human civilization. They are in the forest. Like, people find it difficult to believe that there are viruses 10 to the power, I think 11 or so in 1 liter of seawater. So they can be anywhere. So there are viruses in seawater, there are viruses on forest, and most of them are far away from human beings. Majority of them which are around the human beings are harmless, or they do not cause severe disease. Only limited number of viruses cause severe disease. So that's the thing, but we need to learn to live with them. But one of the challenge which has emerged, that with the human civilization, human activity, for example, our interaction with the forest, like the deforestation is resulting in that viruses which were till now hidden in the forest are coming in contact of human being. And that's how some of the coronavirus have emerged. And that's becoming a challenge, that till now the hidden viruses are getting exposed to human beings. They're causing disease. Like you can remember, we know that this is SARS-CoV-2 is being caused by coronavirus. But there have been coronaviruses which were identified as early as 1920s in the animals, and then around 1960s in human beings. And before SARS into severe acute respiratory syndrome in 2002 and 2004, all previous coronaviruses, known coronaviruses, were causing only mild illness, like common cold. So they were literally harmful, but very smaller way, like common cold illnesses. This is only recent years that we had a SARS-CoV-1, which we call now SARS-CoV-2, and then Middle East respiratory syncytial virus, which emerged in 2012, which is also coronavirus. And this is the third coronavirus, which is causing severe disease. So they are in various hues. It is very likely that some of the coronaviruses or other viruses which do not harm or do not cause severe disease, we do not even pay attention to them. So this one is getting our attention.
I wanted to ask now, coronavirus is a large group of RNA viruses. When I'm talking about RNA, it's ribonucleic acid. That's how you pronounce RNA viruses. And they've got about 26,000 to 32,000 bases. And that RNA, which is carrying a sequence of roughly about 30 proteins. You talked about, okay, they were complex and they are getting less complex here, but then still they are complex and they're different from other form of viruses. Do elaborate on this aspect.
Yes, so majority of viruses have a very small genomic sequence, which means a few hundred genes to a few thousand genes. And then most of the viruses and genetic material in majority of the species, like no matter viruses, bacteria, there is either RNA or DNA. RNA is a ribonucleic acid, DNA is a deoxyribonucleic acid. So there is a different forms, but one of the key differences, RNA is usually single-stranded, coil-like structure, and DNA is double helix or double stranded. Like human beings have a DNA, we know. So most of the advanced species, so to say, have a DNA as a nucleic material because it has some of the characteristic of proofreading and it's more complex. Viruses are relatively simple. They have a limited number of genes, and then they use other platforms like other cells to replicate. So by that standard, this virus SARS-CoV-2 is really bigger. 30,000 base pairs is really high number, and some of the proteins which synthesize. Otherwise, viruses are really relatively simple, like they can have 100 genes or 200 genes, or they are also smaller in size. But what we need to remember that much of the machinery which virus use is not a part of their genomic sequencing, because they have to find a cell outside their genomic sequencing and which they use for replication. And remember, we sometimes make a mistake that viruses are looking for only human beings. No. Viruses are looking for any cell, which could be a cell of bacteria, which could be cell of tomato, a cell of elephant, a plant, or human beings. They are infect everywhere. All they need is a cell, and then they will multiply.
And that's so difficult, right? They need a host and sort of come into your system and replicate. And when you talked about, so there are two things I just wanted to clear. Now, for a layman, let's say, you talk about their size is very small. Could you sort of elaborate on it?
-9. So the key thing is that, let me elaborate on this. In 1918, 1920, we know that influenza pandemic happened. Until that point of time, even the influenza virus was not seen. So the viruses were first seen in 1933. They were identified in 1933 and all seen around 1940s with the advent of electron microscope. So they definitely cannot be seen with the naked eye. And the biggest virus, I believe, is 10 to the power -6. That's small, but then usually a 10 to the power -9. So you require a lot many viruses together. And even then, you will not see with the naked eye. So none of the virus, I think, can be seen with the naked eye. Most of the viruses require electron microscope, and some viruses which are large enough can be seen with a little advanced microscope. So they are really small. That's what you will not see by naked eye.
Size now, it's 10 to the power -9, and that's really infinitely, this actually very small. We're talking about viruses, and we're talking about those vaccines. Now you have Pfizer and Moderna have used cutting edge technology to, in making vaccines. But typically, we know there are three sort of systems a body has for any defense against any infectious disease. You have antibodies, you have killer T cells, and you have helper T cells. And as of course, you would elaborate on how this mechanism works. From what I know is, and as a layman, like the vaccine of Pfizer and Moderna, they basically target spike proteins using the mRNA technology. Could articulate the mechanism how this happens?
So many of us have seen the image, now this is the most common image of virus where there are spikes on the surface of the virus. Now, those spikes are characteristic because other inside material is very similar. So spike have some of the antibody binding portions, which actually receptor binding domains. The spike proteins have something called RBD, receptor binding domains. These receptor binding domains go into human beings and then attach to some of the receptor, such as ACE2 receptor. So that's how virus enters into lungs and other parts of the body. Now, to develop vaccines, what researchers are doing across the world for all the vaccines, that they are looking at those spike proteins and then identifying one of those sections in the spike protein, which is called antigenic. What does it mean, antigenic? That it can result in antibody response in human beings, immune response in human beings, without the risk of causing the severe disease. So in the spike protein, the researchers have identified either all the spike protein as in the killed vaccine, such as we have Covaxin, which is a killed vaccine, which you use the entire virus. It's kind of taking the live virus, then inactivating it, so it has the entire virus. But other vaccines such as even Covishield or viral vector vaccine, and the vaccines Pfizer and Moderna, which use messenger RNA. Now, those messenger RNA mechanisms also carry the genetic sequence of spike proteins. So that's how it is inserted into the body. Now, let me explain this part, that we know that once the disease was reported on 11 January 2020, entire genomic sequence of virus was posted in public domain. So now we know that which part of the genomic sequence reflect or will result in the spike protein formation. So scientists identified that section of genomic sequence of coronavirus, and then researchers started identifying that section which will be part of spike protein, Messenger RNA means they took that genomic sequence,
So,
which we know a scientific formula that which part it is,
so Dr.
and they cover it in the nanoparticle with the lipid, and that becomes a vaccine. So once that is injected in human body, that messenger RNA reaches into a cell, and in the cell, that messenger RNA is used to formulate the protein, which it is designed to or inform. Once that protein, spike protein section is formed in the cell immediately starts thinking that this is something foreign. So they start acting as developing antibody against that protein. So that's how with the mRNA vaccines, once it's going to cell, the protein is formed, the protein is recognized as foreign, and then our body develop antibody, and then person is immune or protected. This is the mechanism it follows. But this is the mechanism also followed in other vaccines. For example, Covishield vaccine also, instead of sending the mRNA or messenger RNA component in the nanoparticles, what Covishield vaccine does, it has a viral vector, which essentially means it is a chimpanzee adenovirus. So chimpanzee adenovirus is taken as a host in which one section of coronavirus is inserted in this genomic sequencing. Now, when that chimpanzee adenovirus is injected into human body, since it has no ability, it's called non-replicable adenovirus because it cannot replicate human body. So once it's injected in a human body, and since it has that section of SARS-CoV-2 virus, which can be immunogenic, so our body recognizes that section and antibodies are formed against this. And that's mechanism every vaccine works.
Let me put it in this way. Now, when we are talking about inactivated vaccine, which is what Covaxin is, the technology behind the mRNA is sort of cutting edge, whereas the inactivated vaccines, they are following still the old system. It's like they are not cutting edge in any way, Covaxin. It's using a very old, which we talked about. Am I correct here, sort of?
Yes, that's very correct. So these killed vaccines are the very traditional form of vaccines in which the entire virus is grown in the biosafety level laboratory 3. And once virus is grown, then it is inactivated through a specific mechanism which are pre-agreed, like formalin and other approaches. So virus is grown in sufficient quantity, then it is inactivated, which means virus is now killed. But it has all the characteristics and quality of virus, and then that portion is injected in human body. Once injected in human body, again our body recognizes that this is a foreign substance, so they start a immune response, and then antibodies are formed. So this is very old, like Louis Pasteur in 1885 developed the rabies vaccine by the same mechanism. Killed vaccine is the same form of vaccine which are widely used, like even polio, inactivated polio vaccine was a killed vaccine, though there is another vaccine, polio vaccine, oral polio vaccine, which is a live attenuated vaccine. Like measles is a live attenuated vaccine. In those live attenuated vaccines, scientific does a serial passage, which essentially means you grow the virus in the laboratory for a certain number of times. And we know that as the virus grow in the laboratory every passing time, its pathogenicity declines. So the measles vaccine, for example, the virus strain which is right now being used is around 240 times serial passage, and that resulted in the reduced pathogenicity, which means ability to cause disease, but improved, retain the immunogenicity, ability to cause immune response.
No, this is fantastic. Now, when we are talking, but this is another thing, if the inactivated vaccine, it's not very easy also to scale up, right? It has its own disadvantages, and also one of this.
Well, they are very safe and effective, but they require usually multiple doses. One dose is not enough in the inactivated vaccine. Second part is that since they require the growth of the virus first, which is an essential prerequisite, unlike the mRNA vaccine, which are laboratory created. So their scale up is really challenging, and they are time consuming process, unlike the other new technology which have been used. But they work, they are very safe and effective. They are proven technology.
In this pandemic, we came to know about a lot of things, like when you're using existing drugs. Now, one great, and I love the sort of phrase which is repurposing of drugs. That's when you already have drugs which could be significantly used for treating COVID-19. And one of the drugs was remdesivir. Now, it was actually discovered to treat Ebola, which was by far has got a mortality rate as high as 50%. That's what I've heard. And that, if you correct me, that is like really very high mortality rate. Now, you also had now the problem here is like the Americans and even the earlier Chinese were very positive of remdesivir. The Americans call it Veklury, that's the name, and they had 3 randomized controlled trials, and we'll come to that at a bit to understand what randomized controlled trials are also. And they found it to be safe for adults which are 12 and above weight of 40 kgs. In the solidarity test was done to find out how effective remdesivir. It was found that it is no longer that effective, as a matter of fact, and which made WHO to remove it as one of the recommended drugs, if I'm correct. Now, contradictory studies coming in over a period of time is because as the data increased, the test was done maybe after, or maybe had an elongated time more than the American test, and you kept on getting data from around the world, and that changed. So this, I just wanted to know if you could throw some light on this.
So we know that SARS-CoV-2 is a new virus. There was no proven medicine or treatment available against the SARS-CoV-2. So some of the experts in the beginning thought that let's try whichever medication works. So remdesivir is known to reduce the replication of the virus. And with some of the early findings, some of the early studies from France and China also, there were indications that it can help in reducing the progression of disease to the next level. But those were the early stage, small scale studies, which gave a good indication. But we know, as an example, somebody who see a clinician who is treating 15 patient or 50 patient, and if he use remdesivir, it's difficult to say whether the benefit was due to remdesivir or those patients would have recovered without remdesivir. So that's what happened. Individual practitioners who were seeing patients and they were prescribing remdesivir, they often reported that this outcome is really good. But we know that science or medical science should be evidence-based. And one of the best tests to test the efficacy or effectiveness of any medication is a randomized control trial. And more so large-scale randomized control trial. Like one side you have a 10 or 15 or 50 or 100 patient with somebody seeing. Other side you want to go for thousands of patients, 10,000, 20,000, 30,000. And in that kind of setup, you can get a better picture whether the drug is really working or it's an artifact. So Solidarity trial was a multi-country trial which had a large number of patients enrolled. And when it was examined, the findings of Solidarity trial, it was found that the drug is not effective. And that's when the World Health Organization and other international agencies said that remdesivir is not effective. So individual opinion are always variable and differ from one individual to another individual. The gold standard in such processes is randomized control trial. Now, let me quickly, 1 minute, reflect on randomized control trial. What is done in randomized control trials, which should ideally be done double-blinded, which essentially means the person who is giving the medication is not aware what treatment is being given. And individual is not aware because he or she does not also know what treatment he or she has received. He might have received, for example, the remdesivir or a placebo.
Yeah,
now we need to
sort of add to the audience, we are talking about here, we are taking a group. Double-blind experiment is like nobody knows, neither the doctor, neither the audience or you can say the people who are under this controlled trials. So there are 2 types of treatment given. One is the original treatment, which is effectively the treatment, and second is what Dr. Chandrakant talked about is placebo, which is a false treatment. Nobody knows who's actually undergoing the treatment and who's undergoing. This is just to remove any bias. So thanks a lot, which you have brought in. This is about interventions. This is to find a counterfactual and factual. This is sort of one of the most important techniques now being used in social impact evaluation. Dr. Chandrakant, you could go ahead.
This is the gold standard in doing blinded for both sides, so nobody is biased. Because if a provider or the doctor is aware that which medication is given, it is very likely that they might be biased to give to somebody who is likely to recover, or maybe biased to give somebody who is not give somebody who is unlikely to recover. So it's completely kept blind, and only at the stage, a particular fixed number of cases which need to be enrolled and followed up, then only the trial findings are opened up. And then experts, individual expert or independent expert independently look at it, the data, and analyze that before arriving on the conclusion. So it removes all kind of biases, or as many biases as possible are removed. And that is really valuable and independent advice. Otherwise, people will argue that no, this worked, this did not work. So, and they look very objectively on the predefined parameters. The trials have an advantage of a predefined protocol, which is followed irrespective of the outcome. And then once the trial is completed, then you know that whether it works or not works, and people need to take that on as a final outcome. Of course, you can do a more large-scale study. So that's what was found on remdesivir and many other drugs, and that's how like dexamethasone, which is such a low-cost drug, was found effective through a recovery trial, which noted that this drug has a particular reduction in hospitalization and mortality benefit. While the dexamethasone is an age-old medication, widely known and really low cost and cheap, available across the world and India.
That was my next question, and good you talked about. But before I go to that, just here so that then the audience gets clear, when the experimentation is being done, somebody knows whether it's a placebo or a treatment. Now, this is another entity. So there's another entity involved, which is doing the experiment, which knows who has got what, but the doctors who actually are going to be analyzing the data and the subject matter, or the people who you can say trial, they are not aware of it. Am I correct?
No, nobody knows actually. So theoretically, what is done, usually the good large-scale trials, there is a coding given to each of the samples. So the packaging should always appear very similar. Mm-hmm. So they are packaged or similar, done very similar packaging, and there is a code on that medication which should be given. Now, what usually as an investigator are supposed to do, they need to run through an identified method, pick a number from the list, and then whatever number is picked, that relevant linked package need to be taken and opened. And so they don't really know. Even the packagers do not know, but of course, somewhere in the system, in that packaging, the record is maintained that the number XYZ which was given is what, and that process is called unblinding. When that kind of thing, somebody becomes sick and a particular outcome is seen or die in that particular scenario. So for that person, the medication number which was given or code which was given to that drug, which the person received, is unblinded, and that is computer generated system. The record is kept there, and unless that is opened, that what was that drug or medication given to that individual, nobody really knows. Everything is computerized and this way. So it's really fascinating and interesting.
This is fascinating because somebody makes it, you have a system, and another entity or an actor is giving, it's like an organization is coming, it's carrying on, you have then another set of actors, doctors or researchers would be coming in, and then the people. Now, this entity also does not know, but they have a coded system wherein they have okay, this particular treatment or this particular, let's say if it's an injection which you're going to be giving in, this particular dose is actually the true and false, 1 or 0, binary, it's how it's mapped. And then at the end of the trial, they come out. Maybe there's an Excel sheet or a sort of a data where they match who got what.
Yeah, so that's how it is. Like, for example, so in the vaccine trials, one individual get a vaccine. For example, in the drugs, it's far easier. You can give a placebo. Like, for example, a medication is given, similar packaging can be done of paracetamol, which is like for fever, but you can administer, or even chalk powder can be used, placebo. But in vaccine trials, usually you need to give an injection, and now you don't want to give an injection of saline or water. So many of the participants in the vaccine trials usually receive meningococcal vaccine, which is a proven safe and effective vaccine. So the person who is receiving an actual vaccine under trial, and then other person who is in the control arm, is likely to receive some other vaccine, which is not the same vaccine, but a very different vaccine. I know, some of the trials, the meningococcal vaccine was given to the control arm. So the people who did not receive COVID-19 candidate vaccine received a meningococcal vaccine, again, which prevent against meningococcal meningitis.
So I have a very good question. That's a very thought-provoking question. But this is very interesting. Let's say I'm within a trial and I get the dose. I get a vaccine, but it's a placebo. Don't you think a lot of times the power of the mind comes in, that even both the treatment and the placebo, they know that, okay, they think actually that they have got the vaccine, all of them. And that might the power of the mind might just distort a bit of trust. Maybe without those trial, they might have done much more poorly against disease or something.
Oh, but definitely. That's how it is. Like, it's a widely proven placebo effect that what they did, many of the researchers did, and on many different aspects. So, for example, somebody who has fever, they were given paracetamol for fever, and then other people who did not have, who had fever, similar group, but they were given chocolate powder, the chalk powder. Now, studies have found that simply giving completely ineffective medication, 30% of people will still recover from that, because that's how your belief and your immune system starts. So that is called placebo effect. If people are simply told that they have been given medication, obviously, unless the situation is really complicated, in common conditions, they recover. Their healing power starts. So that's what happens. Even in the vaccine, that's why you require, because that effect, when we do randomized control trial, the both sides should, we would assume that in the both sides, people will think that somebody who received vaccine would think that they might not have received vaccine, and there would be people on the control arm, they would think they received vaccine, and both sides, it will nullify on both sides.
Yeah, true. You have articulated the concept where you talked about, of course, recovery. Recovery is randomized evaluation of COVID-19 therapy. Talk about dexamethasone, but there is another thing which is methylprednisolone, which is also was one of the drugs or steroids, which is very helpful. Now, when you're talking about these two drugs, especially methylprednisolone, when you're talking about, do talk about when you're talking about steroids, because steroids could also have a harmful effect. They have to be given at the right point in time. That is what. So if you could elaborate about these two, how effective they are, their efficacy in curing exactly COVID-19, but at least delaying it.
So now we have developed a little better understanding of how SARS-CoV-2 progress in human body. And we say that first 7 days are viral phase, which essentially means that the virus multiply in human body in the first 7 days. And then next 7 days are usually immune phase, in which our immune system starts reacting, responding to it. Now, we know that in second phase, especially moderate illness and severe illness, when our immune system is trying to cope up with the virus, sometimes it overreacts. And then when it overreacts, it's called cytokine storm. A number of people who develop severe disease die due to cytokine storm. Now, cytokine storm, in the simple terms, is like if we know that there are police standing at the security at the public places due to any threat and apprehension. Now, their role is just to, if there is some element, like for example, a terrorist appear, then they should try to eliminate terrorists.
Yeah, right.
But sometimes what happens if there are many more terrorists and then police start indiscriminate firing on the street, then of course some of the people, antisocial element terrorists might die, but also some citizen will die. And that's what exactly the cytokine storm is. Our immune system's role is to identify the foreign objects and try to neutralize and kill them. But when our immune system starts thinking that it's beyond my power, I am not able to control this virus replication, so it becomes brings all the firepower and start indiscriminately releasing everything. In that process, what happens? Of course, virus die, but also start damaging our own body organs, and that is called cytokine storm. The word itself is cytokine storm.
Okay.
That excessive release of protective immune things, which will harm the virus or damage this thing. So second phase is really crucial, and we want to a number of mortality, a part of mortality due to cytokine storm. So that it is that stage when corticosteroids are recommended for treatment. Only when in those individuals who are hospitalized, who require medical oxygen, because then the role of steroid is to reduce, to moderate the immune response. Like they weaken the immune system, so our system does not become overreactive and responding to the virus. So that's the role of this thing. Steroids are not required and not recommended in the early phase or when virus is multiplying. Because if virus multiplication stage, steroids start, we give steroid, then our immune system will weaken and virus will multiply faster, and then the disease could become severe. So only at the immune stage where our immune system is overreacting, that time should be given. So scientists have found a very methodological approach when is the right time to give steroids, and that's the right way of doing it. So dexamethasone is one, but methylprednisolone is other one. They are recommended like any of based upon the clinician's preference, but usually they fall in the same category. They work in a similar fashion.
Put it in a layman's term, if I give these steroids at early stage, they might just be attacking cells, or might be protecting you. So that's because it comes as a specialist drug, and like a commando force. And when the commando force is in much before, when you really don't need that particular force, so what you're saying is that they might just destroy those immune system, which might just help, as a matter of fact, fight against the infection.
So we need to understand that to any illness and pathogen, our immune system takes 7 days to prepare for the first time. That's why the vaccines are required, because then with the vaccines, we prime our immune system. So the amount of time which is required to identify pathogen and then prepare immune system is bypassed, because through vaccines, our immune system already knows that which is the pathogen. And so next time when pathogen will enter, the immune system will come in the action immediately. 7 days to 14 days is the time period which immune system require to identify pathogen and start responding to it. So if steroids are given little early, our immune system will not be able to function and identify that, complete that process. And then it will become very difficult for the person to recover and to fight the disease.
Our system, sort of our body, is like intelligent enough to understand what the, to identify a new, let's say, foreign body coming in and to develop pathways to fight it. And that recovery and that sort of memory stays forever. Am I correct here? And
yes, that's very true. There are something. So we know that there are two types of responses, broadly speaking. The antibody-based response, where antibodies are developed in human body, but the other is a cell-based immunity. And now in this cell-based immunity, there are two broad type of cells. So T cells, which are helper T cells. And some of these cells role is directly engulfing or attacking the virus and then reducing the impact. But there are other type of cells called memory T cells, which memory T cells actually remember that which pathogen had attacked. And their numbers are far and few, and they go to bone marrow and stay there forever. But next time when pathogen attacks, they quickly, immediately recognize, like a photograph, that this pathogen has come, and they activate immune system, which becomes active in a few hours and then start responding to the pathogen. And that's how it protects for the long run.
Now, if we take steroids, if it's given at a later stage, you think it's very effective? That's what you would recommend that? Yeah, you're right.
Very effective. Like obviously, steroid has an important role in it. It prevents a fraction of mortality. Not in everyone who receives steroid will benefit. But in comparison of those, like if we look at two groups, one which were given a steroid and other not given steroid, there is around 30% less mortality and progression to the next stage of disease in the group which receives steroids. And it also reduces the duration of stay in the hospital.
That's true. Why I'm saying is that because I also suffered, I'm a COVID-19 survivor. My whole family had COVID-19. Taking steroids, just to sort of just add in last bit on steroids, how long should that duration be? A couple of days, you think is more than enough?
No, it will be determined by the treating physician. It determines that how the person's condition is recovering, improving, changing. That will determine the duration of treatment.
You've talked about mucormycosis, and you've written also an article on that. And a lot of media is confusing mucormycosis with black fungi. Now, mucormycosis is caused by a fungi which is known as Mucormycosis. Now, they both have the same subphylum of fungi, both of them, black fungus and mucormycosis. Sort of actually give what's the difference between actually two? A lot of people confuse and say black fungus is mucormycosis, but then they are not the same, right?
So what we need to remember that fungi is another big kingdom, like the way everything is classified, the animal kingdom, plant kingdom, that way fungi itself is a kingdom. There is a bigger group. Now, fungi comes in various colors, all possible colors you can imagine, and they are there. So that's a kind of thing. Mucormycosis is a fungus which called mucormycosis, and this why this got black fungus name is two factors. One, when this infection mucormycosis or zygomycosis, we also call it the name of fungi. When that infection happens, a person can develop a blackish discoloration over the base of nose and flow to the eye. Also in the palate, there can be black spots. In the nose where fungus grow, it can also cause blackish appearance. So that's how the name colloquially got black fungus. But also there is another factor, that when these fungus mucormycosis is grown on the culture media in the laboratory, between the growth of fungi, there are some black dots appear as part of the growth process. And that's how this has got a name black fungus colloquially. It is not black fungus. Black fungus is a very different one, as you also say. And it rarely causes that kind of illness. It does not definitely affect the sinuses, all of those. So it's unfortunate that it was named the black fungus. But we need to remember that who are the individual who develop this mucormycosis. The individual who received steroids, indiscriminate use of steroid, who had a pre-existing diabetes, uncontrolled one, somebody who has a pre-existing immunocompromised status, or someone who is a long-term hospital admission. These are the individuals who develop mucormycosis. And but fortunately now, since cases are coming down, the number of mucormycosis cases have also gone down. As per one report in India, around 40,000 mucormycosis cases have been reported. Often, the mortality is around 10% till now, but there are still some cases hospitalized.
That's what I wanted to. There's a sudden explosion, mucormycosis cases. Now, of course, there are a couple of reasons, and there was some research done. One is, of course, it could be because of lack of immunity during the steroids if not given at the right time. That was one of the reasons. But one which I came across was very interesting. It said that because of oxygen refilling, India went through a huge oxygen crisis. Now, just to sort of from Lancet, just to get a perspective, early April figured that about 3,842 metric tons of oxygen was consumed in India. By 21st of April, it was more than 8,000 metric tons per day. That could be refilling of cylinders, be one of the reasons for the explosion in the cases.
Well, so all the hypotheses are being explored. There are a number of hypotheses which are being discussed and deliberated that why this happened. And of course, uncontrolled diabetes mellitus is also there. But we have also heard that use of industrial oxygen for oxygenation of oxygen therapy during the COVID-19 crisis is also being explored. Also, it's also being explored that the use of the cylinders for oxygen which were not used and not properly cleaned. However, these hypotheses require some more detailed investigation. We really don't know what could be the cause. More likely due to the excessive use of steroid, individual's immune status, and also uncontrolled diabetes mellitus. But we need to remember that the situation, like the number of cases, is really far and few. If it was due to industrial oxygen or unclean cylinders, it would have been really bigger impact.
Okay, I think, but it's good that we have some sort of investigation into that. But we come to convalescent plasma therapy. I myself am a so that's the reason why I'm saying. I know plasma is just sort of those. It's been used before. It's not like it's been used for the first time, and it helps people specifically with low immune system. Now, if you look at even in America, the US has given emergency authorization use for a plasma therapy. From what I believe is it's still going on. They have not removed it. Do you think the government of India sort of went ahead in dismissing this plasma therapy, especially when you're facing the worst healthcare crisis of all time? Just to sort of, it just blew me apart that why government of India, fair enough, we don't have, I do understand maybe there's not enough of evidence, but there's no negative evidence of, plasma being harming people. But it specifically does help to a certain extent people with no immune system. I just wanted to have a view.
On the convalescent plasma therapy, number of studies have been conducted, and it has been found, especially after the Solidarity trial, and then there was a large-scale study from India, which itself found that the role of plasma therapy is really limited. Now, as we discussed for remdesivir, individual practitioners often were arguing that this is beneficial and this helps patients. But large-scale studies, randomized control trials are the really gold standard. What they found that they are not beneficial. Globally, it was not recommended, but every country has freedom to decide their clinical protocols. So Indian government continued to use plasma therapy on the argument that it might be useful in a very specific subset of patients, and the donor, if the donor has a particular high level of antibody, it might benefit. So in fact, I would say that India continued to use convalescent plasma therapy for longer than globally it was stopped. And now it was only in late April and early May, Indian government stopped convalescent plasma therapy. There is a fairly conclusive evidence that this is not effective, it does not work. And there are too many challenges in identifying donors, and it puts unnecessary stress and pressure on the relatives, because there is a moral dilemma. If you say that this, okay, it might benefit, there is an opportunity cost in healthcare. Person gets stressed, and person try to find out the right kind of donor, while the benefit is really not there. Now it's clear that it does not benefit. So of course it does not do any harm, but there are stress involved, and there is a burden on healthcare system. If you try to get put plasma banks and all those things, it has an opportunity cost there. So medical science should be evidence-based, and the most recent evidence should be used. Of course, it was the right approach to be done last year, July, August, September, when we had limited evidence. But when there is evidence clearly that it does not benefit, it's better to stop it.
It has not stopped its emergency authorization. Am I still there, right?
I think in this case, it must be called investigational therapy. Of course, investigational therapy can be done, and that's what India continued starting October till April. They were saying that a specific subgroup of patients, the investigational therapy can be given. But now Indian experts are convinced that this is not beneficial. Of course, if there is more evidence emerging from other part of the world and the United States is doing, if they are doing it, and these are dynamic processes. As far as the current situation is concerned, Indian experts believe that this is not beneficial, and that's what is being followed.
Fair enough. Now let's come to the Delta variant. That's created like a havoc. There are a lot of every news channel. In one of the recent studies I was reading, it's going to become, I think, 20% of the variant now in the US could be the Delta variant. Now the question here, just I'm trying to understand, is like Delta is, when we are talking about, is B.1.617.2. It's a variant of SARS-CoV-2 from the lineage of B.1.617, and it was first detected in India late 2020. Now, according to, it's one of the most dominant variants now. Here now, I really want to know how could, we have a lot of experts around the world, is to understand how could the government of India, along with the other actors in the healthcare system, and it's a very fair question, be so complacent, which is what, Lancet, everybody have, given their own critique, declaring a premature victory over COVID-19, which is what was declared. And then we came to know what damage that Delta variant has done. And what's one of the worst things is that the Delta variant has been there for a while. It was not that the Delta variant just came in and first recognized in 2021.
Yes, so the variants have emerged starting Alpha variant, which was first identified in September 2020 in Kent, England. And the Delta variant was first reported from India in Maharashtra in October 2020. We know that the viruses have a regular mutation as they multiply. And the higher the transmission in the viruses, the higher the chances of mutation. But every mutation is not relevant. Like there are mutations which are irrelevant or insignificant, but there are mutations which can change in the behavior of the virus. So that's what, when such mutations are found, they are called variants of interest. And then scientists start looking at whether it is causing higher transmissibility, or is it resulting in a breakthrough infection or immune escape, or there is a change in the clinical outcome. Depending upon those factors, if any of those is there, then those variants are classified variants of concern. Till now, there are 4 variants of concerns across the world and 7 variants of interest. Delta variant is one of those such variants of concern, which is like now 90% in India. It's across the world in nearly all parts of the world. Even in the United States, it's becoming increasing rapidly. So this is 50 to 70% higher transmissible. It causes some immune escape. Immune escape means somebody who is antibody due to natural infection can still get infected. It causes breakthrough infection, which means that somebody who has received vaccination, they can also get infection. So this has some of the qualities and more transmissible. It's a challenge. But what we need to remember that this is the fight against virus. As long as virus is circulating, there is a risk of a newer variant. So better we do everything to stop the transmission or circulation of virus.
It got increased transmissibility, but we still don't know how deadly it is. That what we know is that the Delta variant is more transmissible, but really how much does it affect in mortality rate? That's still not clear.
So the severity of disease, we really don't know. The Indian evidence suggests that there is no change in the pathogenicity or severity of disease, the kind of severe disease it caused. But there were some early reports from United Kingdom which found that it was slightly higher severe disease. But we still have to wait because what we are seeing that the number of cases in the United Kingdom has increased, but the number of hospitalization has not increased. So it's very likely that it may not be any different in terms of severity than the previous variant. So
then here we also have that US has one of the best vaccination system, even UK. So if the evidence was coming, okay, that should be looked at, because if you look at the vaccination programs, these two countries have been fantastic, US and UK. A variant of concern, there's another level which the virus could go to. So till now, we haven't got any variants which have reached to that level. Am I correct here? There's another level above level of concern, right?
So yeah, all of the variants are variants of concern, and they like 4 variants: Alpha, Beta, Gamma, and Delta. The Delta variant is the most transmissible. But we also know that Alpha variant, when it was originally reported, it was 50% more transmissible in comparison of the original virus, which was first reported from Wuhan, China. And now this Delta variant is 50 to 70% more transmissible in comparison of Alpha variant, which is already highly transmissible. Essentially, Delta variant is, in comparison of original virus, is nearly twice more transmissible than original virus. So this is always comparative. And if a variant is a variant or additional mutation does not alter in the behavior, we will not notice. So these are the four currently, but there is no doubt that if virus keeps circulating, there could be more variants, could be variants of interest and concern, but it's difficult to predict. All we can do, we can follow. Once identified through the genomic sequencing, such variants can be identified.
This is really interesting, is like, because you have a colossal, one of the worst tragedy which we have seen, the amount of people who have died. It's very hard to fathom. Now, when you speak, of course, vaccination is you are absolutely right that vaccination of the whole, everybody on this planet is like important, because it's going to spread in, and we have seen how something happens in one part of the world, it sort of goes and spreads to the other part of the world. That's true. But come to two very important questions, which is based on some of the things which I've researched and already published. Now, in one of my publications, I think a fantastic, a lot of people loved it, and I would love to know also your views. COVID-19, what did we learn? That's something more of evidence-based, which I've used, secondary research, importance of vaccination, and a very strong healthcare system. Now, of course, of the late, a little bit vaccination in India has come up, but we see we are actually not strong in both of these legs, two pillars at least to fight this particular virus. Just to give you a fair perspective, India has only 0.86 physicians per 1,000 in 2018. Now, if you compare it with China, which is 1.98, now it was 4.25 in Germany and 2.61 in the US. And these figures are from 2017. So I presume they could have gone better, not necessarily. It would be like, of course, one of the vaccination program. And secondly, because you're very passionate about universal healthcare, topic which I think is now so crucial around the world, which is basically not only Indian. I think it sort of is one of the most defining topics in US politics. It's one of the most defining topics for everybody, every human. I think every human in the world has got a right to universal healthcare. So when you're talking about now, looking at the perspective of the facts which I've shared, to talk about the vaccination program and structurally change the healthcare system in India. As an expert, please share, go all out and explain what you would really like to see. Not now, not only now, maybe 10 years down the line, over a period of time, in a decade.
Need to remember that, of course, world will win against the virus. The pandemic will be over. Though the virus may stay, and then we need to follow a particular approach to fight the virus, but world will win against this virus. But I always argue that this victory will be incomplete unless we derive lessons and learnings from this fight against virus. And we have learned many things, that a stronger, well-functioning health system is relatively better prepared to respond to such kind of challenges. We have learned that we require human resources which are well placed and well organized. We have learned that we need a testing services. We need early and easy access to the people to healthcare services. So there are many learning. My suggestion would be that once the immediate crisis at hand is over, the governments, both national government and state government, should sit together or bring their expert together and identify that how these learnings, experience can be utilized to strengthen India's healthcare system. They need to prepare a roadmap for 5 years or 7 years or 10 years, that this is how we will use learning. And that's where we want to see the country go. And India has already committed to universal health coverage through national health policy. Now these learnings should be utilized to accelerate the progress in that direction. And that's how India will progress to USC. But learning is so very essential. If we do not learn, we are likely to make similar kind of mistakes.
And are you positive something would happen? I would love, like, for example, look at expenditure as a percentage of GDP in healthcare. It's very high. I mean, it's about 3%, whatever I read for, and it might be even less if it goes to the system. I don't know how much does it reach. But what we are looking at, opening up more hospitals, making up, much more intense, like the initiatives which America is taking. And we'll come to now know about their one of the fantastic programs, which is like antiviral program, pandemics. Even China, I mean, has invested so much. European countries have invested so much in healthcare, to get that competency going in. And that's what is required, futuristic. Do you see, and as an expert, as somebody whose views are so valuable, to the government, both the state and the central government? You think there is a sort of change of mindset we are looking?
So if you can recall, during early part of pandemic in last year, April 2020, there was a lot of dialogue which was happening, and where argument was that India need to strengthen health system. But we know 15 months since then, there was not enough attention on strengthening health system. So India has that way is not known for following upon the promises. The political leaders make promises, but they do not always follow it up. I think this is the time that we change that situation. It will not happen automatically. The government, political leadership, subject expert have to keep reminding and keep bring attention of government that to happen. That is the only way, and that is the way it should happen.
Rightly, I think it's the communities which is good. Civic societies have to take this forward. That okay, we had enough. Recently, President Biden and his team, they're going to be investing about $3.2 billion from the American Rescue Plan. Now, what's very important is that they're going to be this is the first time a clear-cut strategy has come out that we are not only going to be building, defenses against COVID-19, but we are for now realizing that what the risk of the pandemics could be from viruses. It's not, it was already, there are a lot of reports and which have come out that during the Obama administration also they had, a lot of focus on the future of the pandemic, but then, things do change. But when you're terming up the antiviral program for pandemics known as predominantly as AAP, to prolong strategy in fighting the pandemic, and develop viral pills, which is even much more difficult, so that it could help people who have low immune system who cannot go to the vaccination centers. So this is a very futuristic strategy. How would you comment? What do you think could be the fallout globally?
So we know that it's really challenging to develop effective treatment against viruses or antiviral drugs are really challenging. The first antibacterial or antibiotics were developed in 1913, 1914. Similarly, we know that against HIV/AIDS, there was a lot of research and attention, but it took nearly 20 years of global solidarity, lot of investment before effective medication against antiretroviral therapy or human immunodeficiency virus could be developed. So it takes a lot of time. Then we know now that this virus keeps changing, and with the change and mutations, even the effectiveness of therapies, including drugs, it becomes very challenging. So it's definitely very difficult to predict that when a medication would be available, but it requires a global solidarity, the kind of investment which were done for the vaccines to be also done for the therapeutics for coronavirus and SARS-CoV-2. And that's how it could happen. And of course, the countries such as United States and G7 and other need to take lead because they have a kind of resources, which are required to develop medications. But I would also say that the global community should also work together to ensure that as and when those medicines are available, antivirals are available against SARS-CoV-2, they should be easily accessible to most of the world. They should not be restricted to the limited parts of the rich world.
There are certain things which you talked about and which is mentioned in the book. For example, you mentioned the first antiviral drug came out in 1970s or somewhere around that. So that's very interesting. These small facts. So that's why it makes We Will Win as one of the very important books to read, because you come to know a lot about what's happening in the medical landscape. You're not going to whether it should be freely available, because then there are also trademark issues and people have also invested there a lot. So that's a separate domain altogether. But this could be a platform which I feel for people to also come out and make individually their strategies. What I was thinking is like, okay, America has taken a lead. Of course, China and European countries anyway are following a lot of best practices they're putting in. You have Canada. As a matter of fact, I read a very important study of Uruguay. Uruguay in Latin America did a lot of fantastic things to find they used a lot of technology. And it's a very lovely, if people could read a bit about that country. What here I'm thinking is like, do you think it's time we start thinking about that the risk from viruses are predominantly the most critical risk now going forward?
We are learning about the COVID-19 disease and SARS-CoV-2 every passing day. We also learning that the world is facing emerging threats of emerging and re-emerging diseases because of deforestation we discussed, because of climate change which results in additional pathogens surviving in additional settings, because of overcrowding, unplanned cities, high speed transport, which essentially means an individual can go from one part of the world to another part within. Antimicrobial resistance, which is developing. There are battery farming where large scale animal farming is being done. So all of these factors are conducive for transmission of virus, and even the existing pathogen causing severe disease or affecting additional population. So these are the challenges, and what is the best way to prevent from them? That we recognize that what are the challenges which world is facing and take appropriate actions. And those actions will not be on the health sector only. Those actions will not be that identifying treatments or developing vaccines. There had to be a lot of preventive and promotive interventions. So the viruses does not emerge. They do not enter a new population.
Point which I read in your book is, I think it took 4 years before to make the fastest vaccination was for Ebola, which took about 4 years. Am I correct here?
Yes, that's right, in 1960.
Right. And this is the fastest we've ever built within a year. This is absolutely unprecedented that we have now got a vaccine which is very effective, with efficacy within a year. So that's at least in a way, a lot of, you can say the positive thing is like in the last 1 year, I would say that the medical or healthcare history has taken a quantum leap in terms of sort of the money which came in instead of the concern. Because of the COVID-19, we are seeing the ripple effect in maybe green finance and a lot of other sustainable development goals that people have realized, okay, as a humanity, what happened because of COVID-19? Let's try to look at, okay, equitable education, can we give it to people? A lot of things. That I think mindset is changing. Would you agree with me on this?
Yes, precisely. So we need to really prepare. We need to think that how we can improve the life of citizens all around us, and especially for the emergence of viruses. I would repeat that the focus has to be multi-sectoral, where we think in the climate change, preventing deforestation, we think of safer living conditions for urban poor and slums and all of those. So we need to act on multiple levels to prevent the epidemics and pandemics, and also to strengthen healthcare system to be prepared for any eventuality. Because no matter what we do, there is always possibility of epidemics and pandemics.
And now, please do share any advice you want for COVID-19 or could have, complications. You could talk about any nutrition or anything which you would like to, as a message, share with people who have already suffered from COVID-19.
So I would say 2 or 3 things. One is that we need to remember that though number of cases have come down to around 40 to 50,000 a day from 400,000 a day, which is really declined. But this is still around 4 to 5-fold higher than the lowest of around 8,000 cases a day we saw in February. And what it conveys that the virus is still around. So my advice and suggestion, a request to the citizen people would be that keep following COVID appropriate behavior of face mask. Avoid going to the social gatherings, so weddings or any other program where you can avoid to go. Keep hand washing, because these are the behavior which will prevent us from COVID-19, no matter which strain is circulating, no matter what is the level of transmission. We also need to remember that we need to do this ourselves, not because the government, if you go to public place and if you're not wearing mask, you might be fined. That should not be the approach, or it should not be approach that government is telling us so we should do. We should do because that is the right thing to be done. We can see that Israel, even after vaccination, removed the mask mandate, and now they are going back to mask at the public places. Mask and physical distancing and hand washing. These COVID appropriate behavior are the short way of preventing ourselves from a pandemic of COVID-19 till the world is in the pandemic. And of course, then go get vaccinated as and when your turn come, and if you can get vaccinated. And final part is that all those who recover from COVID-19, it's important that you might have some of the post-COVID symptoms, long COVID symptoms. So keep watching your health. Do not go for excessive physical exertion. Eat healthy, sleep well, take proper rest, and more slowly increase in physical activity. As and when you develop any symptom, consult your healthcare provider. Of course, you have recovered, you will be fine, and one day all of us will win against this battle. In this battle.
Of course, the last question from the middle is the aha question. If you would like to share any message with the audience or any aha moment which comes to your mind.
I think the pandemic period, especially second wave, has been very challenging for the citizen. But people have started getting vaccinated, and this is a good thing. One of the personally satisfying moments for me has been that in the pandemic, I could help many people on the various aspects of disease condition. When I used to receive calls about health condition, and I could advise them over phone, allay their fear. But one of the moments was that somebody, one parent's their daughter got vaccinated, and then she developed some rashes and continuous fever after vaccination. And the parents did not know me. They were in different city. They searched on internet by phone number, and then they contacted me. And like when I heard their condition, I realized that this is a only minor condition. Parents were excessively worried, so I kind of placated them and advised them some of the aspects on vaccine adverse events and how it works and how individuals like to recover. On my advice, they were little calm and composed, and 3 days later I heard from them that while their anxiety had gone, but their daughter who received vaccine and she was having this fever and all the symptoms also disappeared. But so what I realized that sometimes being away from a complete stranger, giving them advice and allaying them fear can really work well. And very most satisfying is some stranger picking the phone, getting my number and then calling me, and from my advice getting benefited. That is the real more satisfaction than anything else which we do in our life, and we try to take fear and fight this virus.
Thanks a lot. I really appreciate. I think the last year we should be very, very grateful to doctors, caregivers, policy experts, healthcare system experts. I mean, you've done a fantastic job. I really recommend everybody that they read Till We Win. It's a fantastic book. It's Dr. Chandrakant Lahariya. I really appreciate you coming, first of all, to the Middle Road platform, speaking up and being very detailed and very helpful.
Thank you very much, Mr. Malhotra, and I hope the viewer and the audience will enjoy the conversation.
I'm sure they will. I think this is a very different and it's a very invigorating and very detailed conversation. Thank you. And you articulated the concepts very well. I think you come across as somebody not only who's a very good author. I mean, of course, there are other people, but you come and you are able to articulate those facts to somebody who's a layman, to somebody who's not much aware of the medical terms. And I think that's a fantastic and that's a very credible tribute.
Thank you. Thank you very much.